Hello, everyone. I hope you are doing well. It's great to be here today. It's also difficult to be a speaker after Andrzej and Mariusz, as they always set the bar very high. And today I'm going to talk about the Sidekiq on the surface, which means the design patterns that we can follow, the good practices that we should apply, and the habits that we should develop in order to build well-functioning background job processing, and Sidekiq under the hood, which is more advanced stuff like Sidekiq internals, the way the Sidekiq communicates with Redis, and for example, how the middleware is working. Before I start, just let me briefly introduce myself. So my name is Paweł Dąbrowski. I am definitely a Ruby guy, and I work with Ruby for the last 12 years. I'm also proud to be the part of the Ironing team since the beginning of the company. And by day, I work as a CTO, and by night, I write a lot of articles. You can find them on my personal website as well as the Ironing blog. I sometimes also post guest articles on the AppSignal blog as well. If you prefer listening to reading, make sure you check the Ruby Rocks and My Ruby Story podcast, when I had the pleasure to be invited a few times in the past. And of course, you can find me on the social media, on Twitter and GitHub, where I share the stuff mostly about Ruby. But enough about me, let's talk about the Sidekiq. I'm sure that most of you know what Sidekiq is. You probably is using this Sidekiq on a daily basis, but just in case you don't know, Sidekiq is a library for a background job processing. It's open source, so of course you can use it for free, but it also provides some paired versions, like Pro and Enterprise. Those versions comes with some useful features like enterprise rate limiting or batches. They are quite expensive if you are a solo developer on a side project or you work in a small startup team. But the good news is that you can easily replace them with some open source stuff as well. Sidekiq is simple, which means that you can easily get started and build the workers, and is very efficient. You can easily scale from few jobs to millions of jobs. It all depends on the way you are designing your process. And the good news is that it works outside the Rails, so that's the good news probably for many of you. And I split this presentation into two parts, as I mentioned before. So let me start with the first one, Sidekiq on the surface. First of all, why should you care about the good practices? Well, first of all, you don't want to annoy your customers. Imagine that you send by accident thousands of duplicated emails to them. This is something that we should like to avoid. Second, you don't want to waste your money. Imagine that you have a process and you expect some errors that you're going to retry. And in most cases, you don't want to log those errors into monitoring service. You only want to log error once if the job would not succeed. And I also will be talking about that, how we can avoid spending money on the monitoring service for errors that we should not log. And the last thing, we don't want to waste time. We want to debug efficiently, and we don't want to search for params that we should pass to the job if we are queuing it manually. So first of all, let's talk about the naming things properly. As a developers, we know that is very hard. And in the past, probably most of us was using the workers term. But about a year ago, the Mike, creator of the Sidekiq, decided to move forward and change the naming to job. Of course, right now we can use both Sidekiq worker and both Sidekiq job, but as a Sidekiq 7, we will only have job on our disposals. So make sure that you remember about it the next time you will upgrade your Sidekiq. The second thing is that we should always use the proper naming for our classes. In most cases, it makes sense to name the class after its responsibility, but I saw many weird cases in the past when one of the developers named the class as Mechanismus. I think the developer does not know what it's doing after a few weeks. So I prepare here two examples. The first one is delete users. In my opinion, is too generic. We don't even know that is a background job. So it's a good idea to give it more meaningful name, like remove outdated users job. And thanks to this, we know first This is a background job. And the second thing, it removes outdated users, which in most cases means users that are no longer active. And the second example is also very generic, is resume processor. So we can as well give it a better name. And I highly encourage you to take a look at your code base to see if you are using meaningful names. Maybe there is a space for the refactoring. It won't take too long. And of course, if your jobs are related somehow, it's always good to create additional namespace, put it in a separated directory, so you have a better clue about the context. In my example, the stripe is the thing that connects all the jobs, so I decided to give it an additional namespace. The next thing is about keeping parameters simple. This one is very important. I think it's fundamental for the background jobs. And the basic idea behind the simple parameters is not only to save the memory. Of course, you can pass some hashes, use many arguments, even pass objects. With the active jobs, you get the serializers and deserializers. With the Sidekiq, you probably have to implement the serializers by yourself. But yes, you can, but it doesn't mean that you should. The idea of simple params is that it's easier to queue them, either manually or automatically. It's easier to find them if you are looking at the Sidekiq dashboard and logs. It provides better isolation, which means also easy testing. And the last thing is that you make the Redis happier, because Redis is in-memory data storage, and if you are providing simple params, it consumes less memory as well. And I prepared here a simple example. As you can see, the first one contains 4 arguments. We are passing only values, and we can easily refactor it, but passing just the reference. So inside the job, we can pull the actual data, and we are sure that we won't end up with the data that is not up to date anymore. The reason for that is not only we are using fewer parameters, but also we should never take the data for granted. Imagine that you queue a job with some values, and those values change in the meantime, and you finish executing the job with the data that is no longer valid. Here is the very simple example of that. We are passing the email, what can go wrong, but imagine that you are queuing millions of jobs, and some of the emails will change in the meantime, and you will most likely end up with sending emails to the wrong recipients. And to easily fix this, just pass the reference. That way you are always sure that you are pulling the actual data. It's very simple, but it's very useful. The next thing is that you should be aware that it is not a good idea to queue the jobs inside the transaction. First of all, we can queue the job and then the transaction will be rollback. And the second thing, even if we would put the queue process in the end, we are not sure that the transaction will be committed before we will execute the job. And this is the problem the Sidekiq is dealing from the beginning. And of the Sidekiq 7, this problem is finally solved. So the big things are coming in terms of Sidekiq. And of course, we should keep the logic simple. It applies to all classes, I believe. But if we have a simple logic inside our jobs, we automatically use smaller jobs. And smaller jobs are very important in terms of Sidekiq. Here we have a simple example. We pull all the websites from our database, and for each website, we scrap the title and save it back to the database. What can go wrong? Imagine that the scrapping process breaks in the middle, so it's not possible to retry it from the moment when it failed. Of course, you can implement some begin rescue and handle that, but there is an easier way for do this. We can easily split the whole process into smaller jobs. As you can see here, for each job, we simply queue separated job. So it's very easy to retry the job. We won't affect the whole process. And you can even easily queue it manually from the console if you would like to. And the idea behind the smaller job is that you can faster process them faster with using concurrency, so you can execute them concurrently. It's possible to queue them manually, as you have to remember only one param. It's super easy and super quick. It's easy to retry job as you are retrying only small piece, and you can easily implement progress tracking. If you are using Sidekiq Pro or Enterprise, you have batches for that with the useful callbacks. But if you are using the free version, you can easily implement it by yourself. The next thing is about the connection to Redis. Of course, if you have a separated instance for your Sidekiq and application, that everything is okay. But imagine that you have one instance, which is a very common case, and your application is not aware of the Sidekiq. They don't know each other, so they are not aware of the connection that you are using, and you can easily run into problem when the connections are gone. There are no more connection, and you will end up with the error. So the very simple solution for that is to use connection pool for both your application and Sidekiq. And also it's very easy because Sidekiq provides some interface for that. You can easily use this block and call your Redis, and you are sure that you won't run out of the available connections. The next thing is that in most cases you don't use inheritance when it comes to background jobs, because there is one big problem with inheritance. You can only have one parent. And imagine the case that you have a few jobs. They are quite similar, but they are not the same. They are sharing some common responsibilities. For example, job A has a handling for error A and error B. Job B has a handling for error A and error C. And we also have job C, which shares the handling for error C and error B. Now imagine handling this with the inheritance. We'll probably end up with the parent class that is very big, that is non-testable and maintainable, is a nightmare. But luckily we can use modules and prepend for that. And while most developers know what is include and extend, prepend work very similar to include. It only takes the module and put it at the beginning of a store chain, while the include will put it after the class. And with the prepend, we can easily create the module. As you can see here, we are rescuing from an error. We are calling super, which will call the perform method from a job. And that way we can easily put the logic into module and prepend it in a job class. That way you can share those responsibilities between the class. You don't need one big parent. You can add as many handlers as you want. And it's super cool because in the perform method, there is no rescue. Everything works behind the scene. And when it comes to errors, we should remember about retrying them properly. And in order to retry them properly, first of all, we have to make sure that we are able to roll back to the initial state. That's why we need a smaller job. Because if you are going to retry the job, you don't want to duplicate anything. You don't want to make any necessary API calls, as this can, harm your performance or do other nasty stuff. And if we are talking about the retrying, which I mentioned before, sometimes we don't want to log errors in our monitoring service. Here's the example from the app signal, but you can also do this for providers like Rollbar or any other. And the idea is that we should not log the error unless it's a final error, because the job might succeed and this error is not needed in most cases in the monitoring service. And to solve that, we can use very simple pattern. The first step is just to create the error wrapper. It simply inherits from the standard error. It saves the reference to the original error. And the next step is to raise it. As you can see here, we are simply rescuing for our original error, and then we raise the job wrapper with the original error inside it. Then we ignore our wrapper, of course. We are retrying, so we don't want yet to log it into monitoring service, as this is not a final error. And the last step is that we can implement Sidekiq retries exhausted. This is a hook that is called when all retries are used, so we can report the final error, and we don't waste our API calls. We don't waste simply money. And when it comes to logging, in most cases we don't need them, but if we need them, we want to make sure that we log only meaningful information that will point us to the problem. And so in terms of Sidekiq, First of all, you should ensure that the logs are saved. Then you should think about the logging job execution. And in the end, you should care about the logging inside the job. And as of Sidekiq 6, you have to take care of the log redirection by yourself. It's no longer possible to configure the log redirection on the Sidekiq level. So make sure that you are saving the logs in a file so you can use them later. And here is the default job execution output. As you can see, we have some useful data like class name or the unique identifier for a job. But if you would like to have the arguments automatically save them, you can easily do this by using middleware. Here is the example of working middleware. You can use it straight into your project. And with this middleware, we get the arguments included in the logs automatically. It's very useful if you are doing debugging or you are looking for a jobs by the params that were passed. And when it comes to logging inside the job, of course, you may have separated loggers, separated files, but if you want to put the information into default log, you can use built-in logger from Sidekiq, and then your message will get this useful prefix, so you can see that they are grouped by the unique job identifier, and knowing the job identifier, you can find all the occurrences of this job. And that's it about the good practices. Let's talk about the Sidekiq internals. First of all, why should we care about the Sidekiq internals? We know it very well. We know how to use it. So why should we care how it's working under the hood? So first of all, I think it's useful to know it, to learn how to extend Sidekiq. It helps us to debug more efficiently as we know how things are running under the hood. And the last thing, it helps us to become a better developer, because I believe that by reading other people's code, we are getting better and better. And here is my philosophy for learning. I wasn't looking under the hood all the time. At some point, it changed for me. So each time I have a new tool to learn, I learn how to use it enough to build something working. Then I improve it to be able to run in production. Then I take a look at the good practices to refactor the code. And in the end, I look under the hood to understand it more, so I can either extend it or even learn how to use it better even more. Actually, there is one step that I missed that we sometimes forget about. It's about the documentation. We should always look into documentation at every step of our learning journey. And I think it applies to all people at all levels of seniority. And as I mentioned before, Sidekiq heavily depends on Redis. It saves the data in the Redis. And Redis is a in-memory data store. It's open source. It's based on the key value pairs. And it provides some data types, sets, sorted sets, lists, and hashes, for example. And when it comes to the process of using Redis by Sidekiq, we can separate this into two steps. The first one is adding job to the queue, and the second one is picking job from a queue. So let me tell you more about adding job to the queue. Here is the typical flow that the Sidekiq is using. So first of all, we are passing params. Then the Sidekiq is validating this data under the hood. Then the assignment of the default params begin. Then the middleware is executed. This is the last chance to reject the job from being saved in Redis. Then the JSON is verified. I mentioned before that it's good to pass simple params, because with the complex object, you may not pass this verification of JSON. And in the current version of Sidekiq, you will only get the warning. But with Sidekiq 7, you will get the error, and your job will be gone to the dead queue, and it won't be retried automatically. And when the JSON is verified, we are finally pushing our queue to Redis, and we are pushing then the payload. So let me go over every step in detail. As you can see here, our call is simply translated to the hash. Of course, if you are planning to execute your job at some point in the future, another arguments will be added. This is the add, and it will represent the time converted to float. Then Sidekiq simply validates our job. It makes sure that the job is a hash. if arguments and tags are in array, if job class either string or a class, and if the add param is provided, it verifies that it's a numeric value. Then the assignment of the default params begins. As you can see here, it will mark your job as retry true by the default. So make sure you will disable it explicitly if you don't want to retry your job. If you won't pass the queue, it will assign the default queue. And of course, it will define some unique identifier and the creation date, which is a time object translated to float. And then the client middleware is invoked. As I mentioned before, this is the last step where we can reject the job from being saved into Redis. And that's how the skeleton is looking. You can have some params at your disposal. You can even use the Redis pool to perform some action or even checks. Then the JSON is verified. As you can see here, the verification is quite simple. And if you are passing very complex object, you most likely won't pass the verification. So I always advise to avoid that. And when it comes to saving data into Redis, we can either decide that we want to perform job later at some point in the time, for example, in the next day, or we can use the perform async to execute it as soon as possible. And in terms, if we want to execute the job later, then the Sidekiq will use zadd command in Redis. It simply add member with score to the sorted set. And when it comes to score, it simply means the time of the job execution translated to float. Thanks to that, we can easily end up with a sorted set of numbers that we can select the right job to the execution. And if we want to execute the job as soon as possible, then first of all, Sidekiq will call the sadd command from Redis. It's simply add member to set, ignore if exists. So thanks to that, we are having a set of queues that are unique. And it perform lpush command for the payload. It simply add item to the head of the list. So we have a simple list with the payloads. And when it comes to picking job from a queue, we have two mechanisms. The first one is a puller. The second is manager. And the puller is generally responsible for taking the job from Redis when it's their time to execute. Then it passes the payload to the manager. A manager is responsible for translating the params into the instance of a job and calling the perform method with right arguments on it. And the puller is using the zrange by score command in Redis. It takes the elements in a sorted set with a score between min and max. And as I mentioned before, the score is a time of execution converted to float. Min is usually minus infinity, and max is the current time converted to float. So it's very easy to take all jobs that should be executed by now. Then the job is passed to the manager. Manager is using the Redis brpop command. It's a simply blocking list pop primitive. It takes the queues as the argument. Then it pulls the job from those queues and execute them. If there are no jobs in the given queue, it blocks the connection and it waits something to appear, and then it executes it. And this is the manager flow in the detail. So it first decodes the payload. If everything is OK, it will proceed. Otherwise, it will push the job to the dead queue. Then the middleware is invoked. So there is the last chance to reject the job from being executed. And then the manager simply execute the job by creating the instance of a class and calling the perform method on it. And of course, we also have the Sidekiq dashboard that is very useful. And under the hood is just a simple rack application that has a views in RB format. And I also mentioned about the Pro and Enterprise versions. Those versions are also gems. You can get them by buying the license. Then you get the credentials. You add them to your gem file. Then you pull them from a private Ruby gem server. And the code is saved to your machine. If you are paying for the license with every year, then you get all the updates on your machines as well. And that's it from my side when it comes to Sidekiq. If there are any questions, then go ahead.
I have a question. You had this slide where a job was scheduled inside the transaction, and you mentioned there was a race condition there. And you also mentioned, if I understood correctly, that the new version of Sidekiq fixes this race condition.
Okay, just let me find it. Okay. Yes.
Yes, this one. And I'm very curious, how does it do it?
You mean how does the Sidekiq 7 will deal with that problem?
Yes.
To be honest, I don't know. The pull request is still opened. They don't have the date for the for the release, so I'm not sure now. I just go briefly through the pull request and read that this is one of the most important things. So yeah, have no idea how they will solve that. But this is something they was experiencing from the beginning, so it's the big one.
So just to make sure that I understood correctly, you're saying that it will somehow prevent the job from being executed before the transaction is committed. Is that correct?
Yes, yes. The job will wait until the transaction is committed to the database, and then job will be executed. If the job is, queue at the very end of the transaction.
Okay, thanks. It sounds impossible, but very curious.
Hello. Thank you very much for your presentation. No, it was very insightful. And I just wanted to comment on that last question because I actually had this exact use case in the other project, and I had to somehow solve this use case. So what I can share here is that, well, that's a pretty common problem when you have two systems to commit something to. So this is pretty universal, and if you don't just commit things to your database, then you will always face this problem. And there are various algorithms how to do it. They have each have its own caveats, but the simplest thing, in my opinion, you can do if you have to solve it now, and probably guys from Sidekiq will solve it pretty well, is well, saving something to the database that will identify your intent to execute this particular job, and then in that job read that from the database, and if it's there, well, it's committed. If it's not there, the transaction didn't execute, and you have to retry a couple of times because the transaction might be slow, and after just a bit of time, you can, if it's still not there, you can discard it. So that's pretty easy solution that scales really well from my experience, that one can use. So it is possible. But it's not simple. There's no simple solution to this problem.
Yeah, I agree, definitely.
One question I have. You mentioned one of the advices is to keep the job simple. And I have seen multiple recommendations how to achieve that, conflicting recommendations. One is to always have job only as a wrapper for your service object call. And another is actually to treat the job as Ruby object and do the logic in there, not to complicate things. Do you have any preference on this, and if so, why?
Well, it all depends, like always, right? But what I prefer is to use some basic checking, right? And then calling some service object or calling API, just to make sure that if you would execute the job multiple times, you always get the same result. We don't want any duplication. So yeah, that's my way of doing it. But it also depends on the case. I saw many examples of simply calling, the service from it. So that's the one. I think that Sidekiq also provides delayed extension, which can turn any class call into the background job by passing the delay, and then name of the method. But it will be removed as of Sidekiq 7. But I think it will exist as a separated gem. So that's another way of doing it.
Thank you for your advices for using Sidekiq. The one question I have is about keep simple arguments for your jobs. I've see a few times in different projects that sometimes developers just put a whole list of IDs, which might have few hundreds of IDs there. Is it a good idea to this, or for example, to just schedule few hundred of jobs in the same time to have single just ID for just one job, or you have another solution for such a list of IDs you need to perform asynchronously?
Okay, so I usually use the batches feature, which takes the mini jobs. You can use it thousands of millions of them, and when they are all finished, you get the the callback, which is usually another background job. So I would go for that if you can execute those jobs independently.
Okay, I never used batches, so I need to read about this and probably.
This is a feature of the Sidekiq Pro and Enterprise, but there are some replacements that are free, so they should work as well.
Okay, thanks.
Thank you for your presentation. Let's consider a scenario where jobs are consuming messages from a message queue, and a lot of messages can concern the same record. Should you somehow decide if any of the jobs following first initial event that was consumed and generated the job, when the jobs are executing one by one, or if any jobs are present already, should we schedule new ones? Just to avoid too much of jobs being scheduled for basically none of the changes that are important for the record.
Well, I think it's a very specific case, but if it's possible, I will execute them one by one, or you can execute a few of them concurrently, but then I believe you have to make sure that you are not overwriting your data, so probably any negative locking or something like that should be applied. But I think it depends on your case. If you can do that, then go for that. You have some special requirements, then I think it needs a bit of investigation to find the right solution.
Thank you for your talk. I'm here. I have a question. Are you interested in why Sidekiq don't work with Redis cluster? Maybe you investigate it.
No, I haven't had a chance to look at it. Yeah, I wasn't aware even of that it's not working there. So
Okay, thank you.
I'm not able to tell you, sorry.
Hi, I have a question about scaling. In cloud computing, AWS Lambda, for example, when there are no jobs to process, it kills all the containers, so you don't have to pay for them, you don't waste any resources. If there is a spike, it spins up several containers, so it can handle all the jobs in a timely manner. And so the question is, how do you scale Sidekiq? Do you have any smart techniques?
Well, we always used many instances of a Sidekiq when we have, a need for a bigger power. To be honest, I never use any Lambda or any of that to replace the Sidekiq or make it more useful. So, it's hard to tell. I think it all depends on the nature of your data, right? Because if you have a unique data, then you have to be very careful. But if you are, dealing with a case where you have a data that can be easily inserted in a database and you won't experience any conflicts, then I would simply go for the multiple Redis instance to achieve that. But if you have some special case, then I think some more advanced techniques may be needed as well. But it's hard to give you the right solution, the bullet one that will work in every case.
All right, thanks.
So I have a question here. Do you have some particular advice how to do back pressure at the application level when you're not? Is the application in some way aware of how swamped the Sidekiq is. And so the application can, in some way, do back pressures and not generate lots of events that you can't handle.
I never did with that case, but I think it's possible, right? Because in Redis you can access to all the information regarding the number of events and the data that is used. So I think it's not that difficult, but you have to plan it wisely and check it frequently, to never miss a place where there is enough, power or the space, and it will become very hard, to continue the process because there are no resources or something like that.
Okay, let's thank Paweł, and we need to carry on with the next session. So
thank you very much.